Hello. I um, I believe you have done this practice. So the reason why it's easy, the answer is 3. The reason why I asked you to do this question is because it's a simplistic example to understand what standard deviation implies. So let's do the math. We have 3 observations, minus 3, 0, and 3. So easy to see that the mean is 0, the middle. Their mean equals to 0. And so deviations are simply self. Minus 3 minus 0, 0, 0. Subtracting 0 is nothing. So then when you square them, 9, 0, 9. And the sample variance, by the way, sample variance, I asked you to calculate the sample standard deviation. So which means denominator has to be n minus 1. The sample size is 3, so you have to divide the sum by 2. So sample variance is the sum of square deviations divided by n minus 1. So it's 9 plus 0 plus 9 divided by 2, which is simply 9. And so this is the variance. This is how you calculate the variance. And then to obtain the standard deviation, simply take square root of this. It becomes 3. So what I want to tell you here is the data are 3 numbers, and center is 0. One of them is the center, the mean, and the others are 3, the distance from the center. The others have the distance from the center at 3. So they are 3 apart from the center. So then in this case, the standard deviation will be 3. If you had minus 4, 0, plus 4, then standard deviation would be 4. Exactly, this confirms our intuition. The standard deviation is a kind of a measure of the distance. So it's the best way to show what happens when you have 3 numbers. When you have 3 numbers, you can clearly see the distance, and that's captured by the standard deviation. Try different numbers, minus 1, 0, 1. The standard deviation will be 1. Minus 5, 0, 5 will be 5. So, and also it implies that the standard deviation is in the same units as the data. So, if you change the unit, then standard deviation will automatically reflect the units. So, it makes it is really easy to interpret and compare. Of course, when you have more data, more than 3, and when you have like more observations with different distances, then standard deviation will be a little bit like murky where what it captures, but the basic idea is still the same. It is the distance from the center in some sense with a special procedure. So this is the standard deviation. So how do we use it? Okay, I just told you that the standard deviation is a measure of the distance of observations from the center. Then it helps us to compare data or two different groups who are in different units, right? Because standard deviation adapts to the different units. So when you have different units, you may unify those units using the standard deviation. Here is an example. Again, suppose that there are 2 students and you have to admit one of them. Let's say you are in the admission committee. You can admit one of 2 students, and the problem is they submitted different scores. Say you are the first student has a GPA of 3.4, and the second student has submitted a GMAT score of 600. So say you have to decide whom to admit to your graduate school. But it's hard to see Who's better? And here, first thing you have to find is the average GPA. You found that the average GPA is 3.15. So it implies comparing the first student to the average GPA. Then you found that the first student is above the average by 0.25. Okay, so he's above average, but also the second student is above the average. So the average GMAT score is 560. So the second student is also above the average by 40 points. So still you can't tell who is better. Both, if one of them was below the average and the other is above the average, then the decision would be simple. But at this point, you cannot tell. You cannot compare 0.25 and 40 because they are in different units, and you don't know uh, who is who is who deviates more from the average. If you assume that the average GPA and average GMAT are at the same level, then what you want to find is you want to find a student who is higher above the average, who deviates more from the average. Now here enters the standard deviation. We additionally assume that standard deviation of GPA is 0.2 and standard deviation of GMAT is 30. Now then, using the standard deviations, we can standardize the test scores, their scores. So remember, student 1 is 0.25 points above the average, and plus 0.25 is, when you compare that to its standard deviation, it's 1.25 standard deviation above the average. So if you interpret standard deviation as a standard kind of unit, typical unit, typical distance from the center of the observations, then and then this student is 1.25 above the average. It's a standard deviation is a measure of the distance from the center. So 1.25 standard deviations is how much it deviates from the average. So we divide by standard deviation. So subtract the mean and divide by the standard deviation. That's standardized score. On the other hand, student 2 was 40 points above the mean, but the standard deviation was 30. So we say 1.33 standard deviation above the average using this standardization. So the score minus the mean divided by the standard deviation is the standardized score. So it's 133. And then now you can compare these two. Both are both now the units are the same as the standard deviations. So now you may compare these two. Then after standardization, student 2, it has the higher standardized score. We call this z-score. Z-score is a common measure we are going to use in theory and in practice. Maybe you may have seen this kind of score. It captures the relative standing of you in relative to the entire distribution. So when you have a test score itself does not show anything. So if I say my score is 560, it does not have any context. It cannot tell how good I am. And in those cases, there are typically two ways to standardize that. One is the percentile score. So 560, I got 560. How good am I? So say then I am at 90 percentile. then it tells you how good I am. I am at within top 10%. So 90 percentile means 90% are below my grade, my score, but only 10% are better than my score. So I am exactly at the top 10%. Alternatively, that's one way. Percentile score is one possible way. But another way to tell the relative your ranking is to use the standardized score or z-score, as I said here. Subtract the mean and divide by the standard deviation. Then it shows how much you are above or below the average. So it's the z-score. So this is a typical formula, standardization process of an observation. Subtract the mean and divide by standard deviation. Then you get a new measure. Usually this standardized number is denoted by z, and it captures how many standard deviations you deviate from the mean, above or below. So if it's negative, it's below the average, and if it's positive, then you are above the average. If it is zero, you are exactly at the center. So it's another measure of relative standing, which can be compared to percentiles. So they are closely related. Percentiles and z-scores are closely related and commonly used in many test scores. So I believe you have seen them. Okay, I am going to stop this video here. And in the next video, we are going to study a little bit different measures briefly. So thank you for watching the video. See you in the next video. Bye.